Hi there, welcome to EduretiX, where we make your high school life simple. I'm Aniket, and today I'm here with the part 4 of the Kinematics practice series for the AP Physics 1 and GCSE papers. In this video, we'll be doing complex level problems. So these would be difficult problems that we're going to solve. These can come in the form of grid-in questions, like free response questions in the AP Physics paper, or the long type questions in the GCSE Physics paper. And sometimes you might see them in the A levels as well as basic questions. So it's highly advisable that whenever we start a new question, you first pause the video, try it yourself, and then only look at our solutions. Let's begin. Okay. A man can swim at a speed of 3 kilometers per hour in still water. He wants to cross a 500-meter wide river flowing at 2 kilometers per hour. He keeps himself always at an angle of 120 degrees with the river flow while swimming. Okay. So let's visualize the scenario first of all. This here is the river. The river's velocity is 2 kilometers per hour. That is the river's flow. Okay. So we can say this is the velocity of the river with respect to the ground. Okay. VRG. Okay. Then the velocity of the man with respect to the river is 3 kilometers per hour at an angle of 120 degrees from the horizontal. Okay. So this is velocity of man with respect to the river. Okay. Now let's combine the vectors. So the speed vector river, this is VRG, this is VMR. Resultant velocity, the final resultant velocity would be somewhat like this. Okay. This would be the velocity of man with respect to the ground, VMG. Okay. So basically VMG, velocity of man with respect to the ground, is velocity of man with respect to the river plus velocity of river with respect to the ground. Okay. Focus on this really carefully because these questions are very popular in AP Physics as well as GCSE Physics exams. Okay. So I'll tell you a very quick and logical breakdown of this problem. Okay. So this is the resultant velocity. Now we don't need to go to a vector addition always whenever we see these kind of things. There are two different velocities in different angles. So we don't need to do the resultant velocity first and then only go ahead. Rather, we'll break down the approach into the exact things that are asked to us. Okay. So part A, find the time he takes to cross the river. Okay, the time taken to cross the river. We know that the river's width is 500 meters. If I take this as the y direction, so basically the displacement in the y direction, SY, is 500 meters for the man. Okay, displacement is 500 meters. Now we'll split the motion of the man into two axes, the vertical axis and the horizontal one. Okay, so that we can split the motion. There will be no need for calculating resultant velocity after that. Okay, so to find the time taken to cross the river, we can simply say time taken is the displacement in the vertical direction, like y direction, SY, upon the velocity, VY. The SY upon VY, that will give us the time taken. Okay, so now for that, let's figure out. So SY is 500 meters. VY, so basically the resultant velocity in the vertical direction. If we look at the velocities, velocity of the river, that's completely horizontal. It'll not have any vertical component. This velocity will not have any vertical component. But this, the 3 kilometer per hour, this will have a vertical component in this direction, and this angle is 30 degrees. So basically VMR cos 30. This will be the velocity in the vertical direction. So velocity of man with respect to river, that's 3 kilometers per hour. Cos 30 is root 3 over 2. 3 root 3 over 2 kilometers per hour. And SY is given 500 meters. Very, very simple. Time is equal to SY 500 over VY 3 root 3 over 2. This is going to be the answer. Now this number looks a bit weird. Why is that? Because we have not been consistent in the units. We figure out the velocity in kilometers per hour, but the displacement is in meters here. So instead of this 500, we'll write a 1 over 2. This is a 1 over 2 kilometers. So the 2 and 2 will cancel. And we'll have 1 upon 3 root 3 hours. This is the time. Okay, if it were to be in minutes, you can just multiply with the 60, in seconds further with the 60. Okay, so the first part is solved without bothering to find the angle of the resultant velocity or the magnitude of the resultant velocity. The second part is, at what point on the opposite bank will he arrive? So basically now in the second part, they're asking us the Sx, the displacement in the x direction, horizontal displacement. Starting point is this. Let's say he arrives at this point. So from the starting point, this here is Sx, the displacement in the horizontal direction. What would that be? Displacement in the horizontal direction, Sx, would be initial velocity, ux, into time, plus half acceleration times square. Acceleration is 0. There's no acceleration in the horizontal direction. So this term goes to, like, gets cancelled. And it's simply ux into t. Initial velocity, or basically the final velocity, resultant velocity in the x direction. Not initial, not final, the resultant. So in the resultant velocity, what are the contributing factors? One is the horizontal component of this 3 km per hour. The other is the horizontal component of the 2 km per hour, which is the reverse velocity, and they're in opposite directions. So let's see what we get. We take the leftward direction as negative, just like the sign convention in vertical and like upwards and downwards, we have the same sign conventions in horizontal. So this is positive, rightward is positive. That means the reverse velocity is in positive direction, but the x component of the swimmer's velocity is in negative direction. So let's do the resultant. So ux or vx, don't take this as initial, this is the combined resultant, is going to be negative 3 sine 30 degrees. This is the x component of the swimmer's velocity plus 2 kilometers per hour, that is the velocity of the river. So negative 3 sine 30 is 1 over 2, so negative 3 over 2 plus 2. This is half, or 0.5 kilometers per hour. Okay, half. So this resultant velocity in the x direction is this. So displacement would be this into time. 0.5 kilometers per hour multiplied by 1 upon 3 root 3 hours. Sorry. Yeah, 3 root 3 hours. This we got from here. 3 root 3 hours, this one. So this is going to be 1 upon 6 root 3 kilometers. This is the horizontal displacement which the swimmer has undergone while going from the initial point to the final point. So you see, splitting the motion is the best part. Like that is the best way to do this, rather than going for the resultant velocity and then solving. Okay. So always try to break down the motion into horizontal and vertical axes. The same suggestion is for projectile motion as well. Don't go for direct formulas. Simply stick to the motion into the different axes and apply the plain and simple equations of motion. Okay, next question. A police officer in a jeep is chasing a pickpocket on a straight road. The jeep is going at its maximum speed V, assumed uniform. The pickpocket rides on the motorcycle of a waiting friend when the jeep is at a distance D away and the motorcycle starts with a constant acceleration A. Show that the pickpocket will be caught if V is greater than or equal to 2AD. Okay, this looks a scene straight out of a movie, a criminal movie where there's a hot chase going on. So let's see how we can use physics in this movie. Okay, so the police officer is in a jeep. Let's say this here is the jeep. They're traveling at the maximum speed V. Okay, and at a distance D apart, this pickpocket is sitting here. He'll be going on a motorcycle and he's starting from zero velocity but with a constant acceleration A. Okay, this distance is D. If he is to get caught, which he will be for sure, so for that, let's say he gets caught at a distance x away. Okay, at point x away he gets caught. So that means the total distance traveled by the police jeep is going to be d plus x, whereas the distance traveled by this pickpocket is x. And so that they get caught, we need to make the time same. The time taken by the police jeep to cover d plus x must be the same or less than the time taken for the pickpocket to cover the distance x. So let's see what time is taken by the police jeep. Okay. That's plain and simple because there's no acceleration. So time is equal to distance d plus x over speed v. This is the time taken. Now this time would be the same time that should be taken by, or greater than this, that should be taken by the pickpocket to cover distance x. So for the pickpocket, we'll write s, the displacement x, is equal to, by third equation of motion, ut, that will be a 0 because u is a 0, plus half a is the acceleration, t squared, t is this time taken, d plus x over v. This. So this is going to result in a quadratic equation, as we can already see. Let's see what equation that's going to be. X is equal to half a d plus x over v squared. 2x is equal to a d squared plus ax squared. We're opening with the a plus b whole squared formula, plus 2a dx over v squared. Be very careful, sometimes we tend to write just this v because it's in the denominator. It'll also be squared, so that'll be v squared. So what do we get? 2xv squared is equal to ad squared plus ax squared plus 2adx. Okay, let's make it look like a proper quadratic equation. So for that, we'll transfer this 2xv squared term to the right hand side. Becomes ax squared plus 2v squared x plus 2adx plus ad squared is equal to 0. Okay. Now, made a mistake, sorry. This, when it gets transferred to the other side, it'll become a negative. So this sign here is going to be a negative sign. Okay. Now, this quadratic equation, for our scenario to be justified, to be satisfied, this quadratic equation must have real roots. Like there should actually be values of x that exist and they are real numbers, such that we can justify that this case would happen. So for real roots, what's the rule in quadratic equations? For an equation to have a real root, the determinant must be greater than 0, which is b squared minus 4ac. That should be greater than or equal to 0 when the equation is of the form ax squared plus bx plus c. Comparing with this form, in our equation, the b would be equal to the coefficient of x, which is 2ad minus 2v squared, that's b, and for ac, the a in our case is a, coefficient of x squared, c in our case is ad squared. Okay, so b squared minus 4ac, let's try to write that in our case. That is 2ad minus 2v squared whole squared minus 4, a is a, c is ad squared, so a squared e squared. This should be greater than or equal to 0. Let's expand this. 4a squared d squared plus 4v raised to power 4 minus 8adv squared minus 4a squared d squared greater than or equal to 0. Okay. Straight away this would be cancelled since they're the same terms. Now 4v raised to power 4 should be greater than or equal to 8adv squared. V squared and v squared terms can be cancelled. So 4v squared greater than or equal to 8ad. V squared greater than or equal to 2ad. V is greater than or equal to square root of 2ad. That's what we were asked to prove. Okay. So this was an interesting question, and questions like this can be very common on the free response section of the AP Physics paper, as well as in the long type questions in the GCSE Physics paper. Okay, so be prepared with these kind of questions. This is how we solve them. Let's go to the next one. Okay, a cannonball is shot with an initial speed of 50 meters per second at a launch angle of 40 degrees towards a castle wall 220 meters away. The height of the wall is 30 meters. Assume that the effects due to air are negligible. Okay, so a cannonball is shot with an initial speed of 50 meters per second, that's given, and at an angle of 40 degrees. Okay, so it's going to follow a projectile motion trajectory, a parabolic one like this, and then at 220 meters from the point where the cannonball is shot, there is a castle wall, okay, which is 30 meters high. Okay, This is 30 meters. This is 220 meters. It's 30 meters high. Now we need to prove that the cannonball will strike the castle wall. That is, it does not go above or beyond the castle wall. That means after 220 meters, like after having traveled 220 meters in the horizontal direction, the cannonball's vertical displacement must be less than or equal to 30 meters. Then only it'll come and strike the wall. Otherwise, it'll go beyond the wall. It'll scale the wall. Okay. So the vertical displacement must be less than or equal to 30 meters. Let's see how we're going to try this. Okay. We'll split the motion into two axes, the horizontal and vertical. In the horizontal one, we have displacement. So Sx is equal to 220 meters. And the initial velocity, Ux, that's going to be 50 cos 40 degrees. Okay. And rest, we don't have any other information. For the y direction, we have Sy should be less than or equal to 30 meters, and Uy is equal to 50 sine 40. These are the two things known to us. Okay. So let's start making the equations. At 220 meters, first of all, we need to find how much time it'll take to cover 220 meters in the horizontal direction. Okay. So there is no acceleration in the horizontal direction because gravity is present only in the vertical dimension. Okay. So acceleration Ax is equal to 0. Okay. So S 220 is equal to Ut 50 cos 40 t, and then plus half at square. A is 0, so plus is 0. So now this becomes 22 over 5 is equal to cos 40 times t. So time is basically 22 over 5 cos 40 degrees. Okay, so let's leave the time at this. We won't solve for the values just yet. Okay, so now we have the time value. Now we'll calculate in this much time or after this time has elapsed, what's the vertical displacement. Okay, so for that, we're going to use the third equation of motion in the vertical dimension. So Sy is equal to Uyt minus half gt squared. Okay, Sy, we don't know. Uyt is 50 sine 40, 50 sine 40 t. T is 22 over 5 cos 40, like we obtained in the last slide. So 5 cos 40 degrees minus half g 9.8 t squared. We'll put the value later on. Now let's solve for the values. Okay, so this becomes 10, so 10, so this is going to be 220 sine 40 or cos 40 is tan 40 minus 4.9 t square is 22 over 5 cos 40 degrees squared. Let's see the value. So 220 tan 40 is going to be 184.6 minus 4.9 times 22 over 5 cos 40 is a 5.77. The squared would be 32.949. Okay, and this is going to be 184.6 minus 161.675. Clearly we can see this will come out to be something around 23 meters. So the displacement, vertical displacement, is less than 30 meters, and hence the cannonball will for sure strike the castle wall. Okay, so the question was a bit calculation intensive. Let's see the next few parts. Part B, how long will it take for the cannonball to strike the wall? We've already solved for that. Perfect. So how long will it take? This is what it'll take. Basically the time taken for the cannonball to cover 220 meters in horizontal displacement, and that's 22 over 5 cos 40, the value of which is going to be 5.77 seconds. Okay, this is the, Answer the second one. At what height above the base of the wall will the cannonball strike? Absolutely perfect. We've already solved for that. It's approximately 23 meters. See, this is the magic of solving in the right way right from the start. So we took the right approach, and that is why we were able to solve all the three parts at once, because they have given the parts in that way only. Okay, so this is good. The question was pretty interesting and a bit calculation intensive, so make sure you don't make any calculation mistakes here.